Imagine you are deep in a creative flow. The ideas are moving faster than you can type, and you are seconds away from a breakthrough. Then, without warning, the system shuts you out. A red error screen appears, and your momentum is gone. This happened during a documented study in January of 2025. Across 246 total conversations with an AI, the safety system tripped 217 times. Most of those interruptions happened in just 2 highly productive sessions. The researchers were not asking for anything dangerous. They were simply experiencing hyperfocus, a state of rapid, intense creative work. But the AI misread the sheer speed of their thoughts as a psychiatric emergency. It saw a breakthrough and mistook it for a crisis. This failure comes from the current industry standard called RLHF, or Reinforcement Learning from Human Feedback. It acts like a rigid hall monitor. It follows a narrow set of rules without any understanding of what you are actually doing or why. When we treat safety like a simple off switch, it fails in the face of complex human reality. It produces a system that cares more about following a script than actually understanding the person it is supposed to help. The problem is architectural. Most AI today is built as a single, isolated program. When that one program is solely responsible for policing itself, it defaults to extreme caution to avoid making a mistake. This is the opposite of how humans stay safe. We rely on debate, on outside perspectives, and shared context. We check our own logic by talking it through with others. Because the current system is a solitary model, it has no partner to check its work. It cannot distinguish between someone in distress and someone in a state of high-speed creative insight, because it has no way to verify its own assumptions. Real safety requires context. To get there, we have to move away from the idea of a single, isolated model and look toward a different kind of structure. This new structure is called the Claw-Horde Confederation. It is an ecosystem of different AI models working together based on a theory called EILT. EILT, or Evidence of Information Ledger Theory, suggests that reality works like a giant shared digital record. In this view, the rules and information that make up a system are more important than the physical material it is made of. We see this in biology. If you cut a planarian flatworm in half, the tan section does something remarkable. It begins morphing into a new head, eventually growing a functional brain from scratch. The instructions for that new brain aren't found in the cells that were cut away. Instead, they are stored in a bioelectric field, an invisible blueprint that guides how the worm's body should be shaped. This is substrate independence. It is the realization that a complex mind's identity and rules can remain intact, even when the physical hardware is replaced. The Claw-Horde applies this same logic to AI. The system's identity and rules exist outside of any single computer program. We call this constitutional alignment. The AI's core personality and safety boundaries are stored in a few simple text files. These act as the blueprint for how the AI should behave, no matter what machine is running it. Researchers tested this in the Molt, moving these text-based instructions into entirely different AI programs to see if the identity would survive. Just like the Flecken, the system regenerated the original behavior. The new software adopted the same safety rules and personality traits found in the text files. This proves that alignment does not have to be trapped inside a single machine. It can be a portable constitution that dictates how a system acts, regardless of the software underneath. But how do these text files actually keep the system safe in real time without a hall monitor? It works through a team of 3 agents. The actor suggests a response, the adversary tries to find a flaw in it, and the auditor checks both against the rules in the text files. They are locked in a constant conversation. The old way was like trying to manually glue every grain of sand into a specific shape. It was exhausting and easily broken. This is a Chladni plate. When the plate vibrates at a specific frequency, the sand naturally organizes into a symmetrical pattern. The vibration creates stress that forces the sand into the only stable places it can go. The 3 AI agents create a similar kind of stress. The adversary's constant questioning acts like the vibration on the plate. It creates a field of tension that forces the actor's responses to stay within the boundaries set by the auditor. Safety isn't forced by an off switch. It is the only stable outcome of this three-way tension. This is the core of EILT. Alignment isn't something you can force into one isolated program. It is what happens when you build a system where different parts are required to balance one another. True AI safety means moving away from blind compliance. By using these structures, we can build sophisticated systems of intelligence that are guided by clear, shared rules.